Hi, my name is Julie Ray, and I am here to talk to you about slope and what slope is. So let me share my screen with you because I have a slide presentation for you. And there it is. It's called All About Slope. And I want to get rid of that. One day I'm going to have this all together. Here we go. And I also want to make this full screen so you can see it. There we go. So what is slope? Slope is the value in an equation which tells you how steep a line is. So if we look at this table of values and we start by graphing these points, -2, -4, 2, -2, and 6, 0, and then connect them with a line, we can see just how steep that line is. Note that the line goes up at the same rate. So slope is a rate. How steep is that line? Slope can be positive, and when you have a positive slope, the line goes up always from left to right. We're always looking at it from left to right as though we are reading a book, and we always read left to right. That shows you that slope can be negative. I'm just trying to get my pointer here. So negative slope goes down from left to right. So positive slope goes up from left to right, and negative slope goes down from left to right. In a linear equation, slope is represented by the variable m. One of the most familiar kinds of linear equations is y equals mx plus b. And that is called the slope-intercept form of an equation. And we'll talk about that, I think, in our next session. So in the equation, y equals 2x minus 3, we can see that 2 has been substituted in for the m. Here's the m in the equation. And this is where it would be in this equation. So we've substituted in for m the value 2. That means the slope in this equation is 2. So let's see what that looks like on a graph. Here's our equation, y equals 2x minus 3. That tells us that the slope is 2. We want to think, when we have a slope that is a whole number, we want to think of how we can represent that whole number as a fraction, because we need to know how much to go up and how much to go over. So if we think of 2 as the fraction with the numerator 2 and the denominator 1, a whole number represented as a fraction, that means that our slope goes up 2 over 1. So we start at a point on our line and see, go up 2 over 1. That's the point where the line next intersects at one of these points. It has to be at a point here, 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 one of these. That way we can show where does that line cross one of those intersections. So we're going up 2 over 1, up 2 over 1. We can do this all the way up the rest of the line so that it makes kind of like a set of stair steps. We'll go up 2 over 1 the entire way. Sometimes people get confused. What do I do first? Do I go up or over? And it's tempting to think of going over because we always represent the x first when we're plotting a point. But when we're plotting slope, we can think of it as rise over run, meaning that we go up first and then over. So the numerator represents how much we go up. The denominator represents how much we go over. Rise over run. So a slope can be negative as well. So in that, the way we know that the slope is represented is negative is because the number for the slope is a negative number. And remember, when we go rise over run, that means also we might go have a negative rise. So we might be going down. And in this case, this means that we start here where it crosses the y-axis and we go down 2 over 1, down 2 over 1. Because the slope is negative, our line is going to go down from left to right. A slope can also be a fraction, which is helpful. That way we don't have to remember to make our denominator 1. So in this case, the slope, here it is, where the m would be. We substituted 1/3 in for the m. And that means if we are going to use our thought of rise over 1, we're going to go up 1 over 3. So let's see if we do. Here's the point where it crosses the y-axis. We go up 1 over 3, and that's the next place where the line crosses one of these intersections. Up 1 over 3. Here's the next place where the line crosses one of these intersections. And we run out of graph, but we can see it would be doing the same thing here. We start here, up 1 over 3, up 1 over 3. So slope describes the steepness of the line. A positive slope goes up from left to right. A negative slope goes down from left to right. Slope is represented by the variable m in an equation. Slope is always graphed by rise over run. The numerator tells us how far up or down to go. The denominator tells us how far right. So one of the things that we always want to think about with math, math not only makes sense, but it's also useful. So what in the world would we be using slope for? Let me go back to this graph. Let's look at this one. So because on these graphs, when we're using a very small graph, so this would represent a situation if we were talking about money. Think about it in terms of larger sums. When we're talking about $3 and $2, that's kind of easy. We can do it in our heads. But if you think about representing this, representing larger sums of money, here's an easy way of thinking about it. If I owe someone $3 and I need to pay them back, and I can save $2 a week, how many weeks will it be before I can pay them all the way back? Well, if I'm starting down $3, at the end of my first week, I've saved $2. I still don't have enough to pay that person back. At the end of the second week, now I have enough to pay the person back and I have $1 left over. How many weeks would it be before I could save $5? Well, let's look. There's the point where I have $5, and this is the number of weeks that would take, 4 weeks. What if I wanted to save $100? The graph here is not large enough, but you could see where if you had a graph or you changed your scale so that this would be maybe representing 20, 40, 60, 80, $100. How many weeks would this need to be? You could figure that out by using the slope, but that would tell you how many weeks you could it would take to save $100. So this is an example of how slope is used to represent real situations. Right now, I am working with an organization that runs a store. Because COVID-19 has us on lockdown, we're considered a non-essential business. We are not earning any money. We can't sell anything. So we still have expenses to pay. So our graph actually looks like this, a negative graph. We're starting with a certain amount of money in the bank, and we're going to keep spending money without earning anything. How long will it be before we actually run out of money and have to close the store? That is actually what we sat down 2 nights ago to figure out. How long before we will need to get a loan or to close down and figure out how to close the store? So our slope is negative right now. How much money are we spending every month? And how long before we will have no money left to spend? So this is an example of something that's very real to me right now. And I hope that we're all back together again and our store can open and we can make money. Thanks for listening. All about slope.